Yeah, so today is March 15th, 3:15, and it's interesting. I don't actually even know what to call these notes. There's not really a great name for it. It's like we're going to multiply radicals, and then we're going to, so we could call it like construct and deconstruct, I guess. That would be a cool name for this. So we're going to build and then destroy, which to anyone with an IQ over 31 seems like, why would we do that? So I'm on your side if that's what you're thinking. Like, why would we put it together just to take it back apart? Like mathematical Legos or something, but it's not quite like that. There's a method to this madness. So we're going to construct and deconstruct square roots. So as an example, I could give you something like the square root of 5 times the square root of 8, which, as you know, if those were the branches on one of our trees, your teacher would probably tell you, yeah, thanks, but no thanks, right? And we don't like 5 and 8 because they're not rootable. So what we're going to do today is we're going to put radicals, ironically enough, back together and then pull them apart in a different way than they were before. So I don't like 5 and I don't like 8. So if I multiply those two radicals together, what do I get? I get the square root of 40. And now we're going to show this problem who's boss. We're going to say, I would not use 5 and 8. What would I use? 4 and 10. And so if you like the tree, you can make the tree. If you've taken a liking to that other new method, you can use it even just for simple ones like this. You could take inside and do it like this if you don't like the tree branches. Same thing. And what's the square root of 4? So having broken this down now a different way, we arrive at the answer of 2 root 10. Mm-hmm. Yep. So let's practice again. What's that? Of course there are. Geez, you didn't think you were going to get off the hook that easy, did you? Come on. I guess. I mean, depending on, I don't know what you consider to be harder, but let's see. So far. So we'll just jump right to it. There's really no sense. There's some more number ones and we'll talk about those, but I just jumped ahead. I thought, thanks to Koi's question, I thought, let's just segue right into the good stuff. So those radicals on their own are not to be worried about. What we're going to do is we're going to melt them back together by multiplication, and we're going to create one big radical. So this is going to equal the square root of what? No, 120 x to the 6th times y. Right? Don't forget your rules of exponents, that when you have x to the 3rd times x to the 3rd, you add those exponents together, 3 plus 3, not 3 times 3. The only time we would multiply them is, remember, if it's a power with a stacked power, which this is not. So now we just wind up with a math problem that I would reckon we're relatively comfortable with just because it's what we've been doing. So at this point now, I'm going to take that square root of 120 x to the 6th y, and I'm going to do the good guy, bad guy thing, making a longer radical. And I'll give you a moment, I guess, or two, if you need them, to help me find the breakdown of 120. Yeah. And I was going to let you search for a while, but I also want to give you some work time today. The answer actually winds up being 4 times 30. And I always have felt like 30 is one of the most cruel numbers that you can give to kids, because don't you feel like 30, you got to go further? I've always thought 30, what a weird number. But if you take all the ways to make a 30, like 2 times 15, dog water. 3 times 10, no thanks. 5 times 6, no bueno. So there is no way to break down a 30. And so even though it feels like this is incomplete, 4 and 30 is the best we're going to do. So I'm going to circle 4, calling him a good guy. And now I'm going to look at the x to the 6th. What do you think about x to the 6th? Leave it or split it? He's a good guy already, so we just leave it. And then, of course, y we can't do anything about. But I am going to circle x to the 6th. So when I take this now and I break people out of jail. 4 is the first jailbreak. What does 4 break out as? A 2. And what does x to the 6th break out as? Good job. And then we've got the guys serving life sentences inside the square root prison, and they are 30 and y. Right? That's not scary, is it, quite? Really, it's just the only new thing today. And there's one more example I want to give you just because I need to. But really the only new thing today is this step of putting these 2 square roots together to make the 1 that we will then subsequently break down a different way. It's not that bad. So you're going to see some problems also that look like this. -4 times the square root of 80 times 5 times the square root of 32. Bless you. Yeah. So in this case, I'm going to go against something. In this particular example, go against something, and I'm going to come up with another example because I don't really like this one in hindsight. But I would take, in a case like this with the bigger numbers, and I would be inclined to break these down first. So I'm going to take this one and break it on its own. I'm not going to put these ones together because 80 and 32, if I multiply those, I get like 2,560. No thanks. So I'm going to attack them when they're out in the open. So I'm going to break the square root of 80 into, of course, 16 times 5. You've seen that one a lot of times by now. And then what about the second one? How do we break down a 32? Good job, you guys. No one said 4 times 8. Bless your heart. Good job. And then I'm going to circle some good guys here. So 16 and 16 are good guys. So let's talk just individually. Let's talk blue box. What does the blue box wind up equaling? -16 root 5. Well played. And then let's switch colors here and let's go green box. Very good. 20 root 2. Right? If that's vexing to you, you're just still too slow on your roots. Yeah, it's okay. It's what the practice will help you. I can give you tons more practice worksheets. I can make them by the hundreds. Just you got to get really good at seeing those repetitive numbers. They keep popping up. And now I would take and put it all back together. So I'm going to take -16 and I'm going to multiply it by 20, and that's going to equal -320 times the square root of. Final answer. Still good? Okay. And I'm going to take one actually off your worksheet. So when you get to this problem, you'll know, because I like this problem and I'm going to steal it. So full disclosure. When you see this again, you'll go, I got the answer, baby. -10 root 3 times -2 root 21. So this, contrary to the last problem, is not one that we can break them down individually. It's not possible. And we wouldn't really want to anyways, because these numbers aren't intimidatingly large. So we're going to jump right to it and we're going to multiply. So what is -10 times -2? Good job. So we have 20. That's not a root. You don't try to break that down. People sometimes say, do I break that? You don't break it down. You only break down roots, right? And so then I take the root 3 and the root 21 and I multiply them. What do I get? Root 63. So what I've done, just kind of like the first couple examples, is I've mashed up 2 roots to make a bigger root that I will now break a more intelligent way than was given to me. And so the 20, I'm just going to leave there. How are we going to break down that 63? 9 and 7. So we're going to do 9 and 7. What's the square root of that 9? 3, which then breaks out of jail and multiplies by 20, making nice. You guys think you can handle this? Yeah. All right, great. Well, I won't make this take any longer than it needs to.